Kasturi Day. Today I'm starting with a new chapter on physics of class 9 syllabus ICSE. This is laws of motion. So before I start, I will request you to please concentrate. Please to subscribe my channel if you have not subscribed yet, and please to ring the notification bell because this will notify you as soon as a new video is uploaded. Okay. And if you are liking the videos, press the like button, share it with your friends so that they can also be benefited from these videos. And please to meditate before you start. So before I start, I will request you to please to concentrate on the point of light for meditation for just 1 minute. Okay. So concentrate on the point of light. Okay. Start with the discussion. So before I start, I'll tell you that this is the chapter of laws of motion, which is a physics chapter according to ICSE syllabus class 9. Okay. So first, when there is motion, so there should be a force which acts on it, okay, which act on a body, which causes the motion. So what is that force? Force means a push or a pull which is acting on an object is called the force. Okay? And the SI unit of force is Newton, denoted by capital N as symbol. And it is used to perform various activities. Commonly it is push or pull. Now, what are the effects of force? We now know what is force. Now, what are the effects of force? That means what force does to us, what force helps us to do. Okay, so force can change the size and the shape of the object on which it is acting. So we know that one can push and one can pull. That is force. Okay. But it can also change the size and the shape of the object. It can make the object to start moving, to decelerate or accelerate. So what is that? If a body is still, the object is standing still, then you can make that object move by applying force. You can, when a body is moving, you can decelerate its motion. That means you can lower down its speed by applying some force, or you can accelerate its speed by giving some force, extra force you can add to it, and it will move more faster. So when there's an interaction between two objects, they exert a force on each other which are equal in size but opposite in direction. So when there is an interaction between two objects, say two balls, one is a iron ball and one is a rubber ball, for example. So these two objects are there. Now when they are coming close to each other, okay, when they are in contact or they are close to each other, then what happens? There is an interaction between the two objects. Then what happens? They are exerting a force to each other, and which will be equal in size. That is, both will apply same force and they will be opposite in direction. One force will be acting magnitude and direction. That is why it's a vector quantity. Now, in the cases when the body is in motion, the energy of its motion can be quantified as the momentum of the object, that is the product of its velocity and mass. So, when the body is in motion, the energy of its motion can be said that it's the momentum of the object. When the body is in motion, when the body is moving, then the energy of its motion will be equal to what? The momentum of the object. That means what? Momentum means velocity into mass. Clear? So when the body is in motion, the energy of the motion will be equal to momentum, and that is equal to velocity into mass. But when the body is free to move, when it is moving freely without any force, then its velocity will be changed by the force of action. Velocity can be changed by the force of action. Like a ball is falling freely, then its velocity can be changed by the force of action. If you apply a force on it, then it can stop. So when it is moving freely, you can change its velocity by applying some force. Next is effects of force. Excuse me. So what are the effects? That is, therefore, the action of a force can cause what? A stationary object to move, a moving object to change its speed, a moving object to change its direction of motion, or an object to change its size or shape. So these actions can be done by a force application of force. So what are these? A stationary object can move, a moving object can increase or decrease its speed, or it can stop. A moving object can change its direction of motion. An object can change its size and shape. Okay. Now we come to some examples. The forces can make a stationary object move or make a moving object move faster. Okay. Like, for example, a toy car can be made to move by giving it a little push. A toy car, when it is moving, we can move it when we give a little push, it will start moving. If it is stationary, it will start moving. If it is moving, if we apply some force, it will move a little faster. Okay. The stationary football, if a football is stationary, it can be made to move by giving a small push. Same thing by kicking it. Then small pushes by kicking. If we kick the ball, it will move. Then an already moving toy car or a ball can be made to move faster by giving it a push in the direction in which it is moving. Thus, the force can make a stationary object move. It can also make an already moving object move faster. Clear? This is effect of force. A cyclist uses a bigger force to pedal his bicycle and increases its speed. That means a cyclist was moving by paddling his bicycle. Now, if we apply more force, bigger force by more paddling its bicycle, then he can increase his speed. Here, so this is applying the force. Then, a force can slow down or completely stop a moving object. So, what happens? If a moving car can be made to stop by applying some force. If car is moving, toy car is moving, then you can apply some force and the car will stop. Then a bicycle can be stopped or slowed down by applying the brakes. If we apply the brakes, then the bicycle can be stopped moving or it can slow down. Then the force applied by a goalkeeper stops the ball that is hit towards the goal. Okay, when players hit the ball towards the goal, then the goalkeeper will stop the ball by applying some force. Okay, then therefore, that to stop or slow down a moving body, a force is applied in the direction opposite to the direction of the motion. If if we want to move a body which is stationary, or if we want to move the body a little faster, if we want to increase its speed, then we will have to apply some force which will be in the direction of its motion. But if you want to slow down or completely stop a moving object, then we will have to apply a force which will be in the opposite direction of its moving of its motion. Next example is of force can change the direction of the moving object. Now, a batsman can change the direction of the moving ball by hitting it that is bowled at him. In a cricket condition, in a cricket stadium, when a batsman is bowled, ball is hitting its bat, then what happens? He will hit the ball in a direction, and it can change by hitting that ball. Change the direction of the moving ball by hitting it. Okay. Then the players of the football team can change the direction of the moving ball by kicking it in a different direction. Therefore, force can change the direction of a moving. Next is like this, see, the goalkeeper, he stops the ball. Okay, then footballer can change the direction of the motion of the ball. Here, the bicycle, the force can be applied of the moving object by changing its, it can increase its speed or it's decreasing its speed by applying the brakes. Next, a force can change the shape or size of the object. How? Like, for example, while making chapatis, when we are making chapatis, the size, the shape of the dough can be changed by applying force with the hands. It can be made more flattened by applying force by your hands. Then the shape of the rubber band changes when it is pulled. When you stretch the rubber band, the shape of the band will be changed. Then things can be broken by applying force. Then the materials that break easily when the force is applied are termed as brittle. But what is the thing? That is, a force that can be applied to make the material smaller. So size can be made small by breaking it. So by applying force. Breaking means by applying force. Okay. For example, objects made of glass and clay break easily when force is applied on them. Okay. Therefore, force can change the shape and the size of the objects. Here, see, this is the examples drawing. See the spring. If it is stretched, then it increases its shape. Okay. Then we are making this by applying force. Okay, like the doubt when we are making chapatis, we can apply by applying force. We can increase its size. Okay, so the shape can be changed. Here also, the can is the shape of the can is changed by applying force. By hammering it, by applying force, we can change it by hitting it hard. Okay. Here also, the sponge can be made smaller by when it be squeezes. The size can be changed. Now we come to kinds of forces. How many types of forces are there? Mainly, there are two types of forces: contact force and non-contact force. The contact force can be applied force or muscular force, frictional force, normal force, tension force, or spring force. Okay. Force which is exerted by spring. Now, non-contact forces can be magnetic force, electrostatic force, or gravitational force. So next we come to the details of the forces. So first we come to contact forces. Contact forces means what? The forces which act on the body when they are in physical contact. When they are in contact with each other, then what are the forces which are acting on the bodies? That is known as contact. Like in the picture, you can see a contact force is a push or pull on one object by another that is touching it. Contact forces can be weak or strong. Okay? Like the heavy load which is applied on the cart, okay, and the cart driver, he is pulling this thread to make the cows move forward, okay, to move the wheel forward rather. So all these things, what happens? There is a contact force. Okay. Here, the boy is touching the ball and then it is hitting. So there is also an applied contact force applied. Here also, the person who is pulling the luggage or the hard object. Okay, so he is contacting with the thread or a rope, okay, while pulling it. So there is a contact between the objects, and therefore this is contact forces. Contact forces. So now we come to the examples of the different types of contact forces. First is frictional force. Okay? When a body slides or rolls over a rough surface. Okay? When a body slides or rolls over a rough surface, then a force starts acting on it in a direction opposite to its motion along with the surface in contact. And this force is known as friction. So what happens? Like if there had been no frictional force, then we could not keep any object or anywhere. Okay, or rather we would have fallen down. So there has to be some frictional force. So what is that force? So if we keep a book on the table, if we keep a book on the table and just pull it, so what will happen? The book will fall. If we pull it, if it is smooth, very smooth, okay, then if the book is sliding down, so the frictional force will be less than the force of the pull of by me. So it will fall down, slide down. But if it is a rough surface, like say a rough wall, okay, on which the book is kept. So what will happen? If we pull the book, it will not easily come. Why? It will not slide. Why so? Because a force is acting which is opposite to the pull which is given by me. What pull which I am giving, that will be acting opposite to the force which is stopping the book to come forward. So that force is known as frictional force. So that opposite direction of force is frictional. Diagram you can see the boy is pulling the table from the on the floor. Okay, so the boy is pulling it, so that force is applied, but a force is stopping the object to come forward to him. So that opposite direction force is known as frictional force. See the arrow. The red arrow is pull, shear reaction force, okay, and the blue arrow is stopping the force, stopping his force, his pull force, okay. So that is frictional force. Here, next we come to normal reaction force. When a body is placed on a surface, the body exerts a force which is equal to its weight downwards on the surface. So when a body is placed on a surface, if you place a body like this, it will have a force which will be equal to its weight, which will be acting down on the surface like this. Okay. But the body does not move or fall because the surface exerts an equal and opposite force on the body normal to the surface. This force is known as body. When a body is kept like this, okay, like this is the surface, or a body is kept like here. Okay. So there will be a force acting downwards, like, which will be equal to its weight. Another force will be acting upward, which will not allow the body to fall down. Opposite to it. Equal. That will be equal and opposite. So that force is known as normal reaction force. That will be normal to it. That means at 90 degrees to it. So that will be equal to normal reaction force. Here, from the diagram you can see the car is moving upward. So when the car is moving upward, a force of its weight equal to its weight will act downward like this. The frictional force will be acting like this, which is allowing the wheel not to fall down. And the normal reaction force will be acting normal to the car, that is perpendicular to the car. So that is normal reaction. Next is tension force. What is the tension force? When a body is suspended by a string. So if we suspend a body by a string like this, it is a falling. It is there's a like say a pendulum. With a thread, we just hold the pendulum thread at the top, and we hold the string with the pendulum bob at the lower end. So the body is suspended by a string. The body, due to its weight W, if it has a weight W, will pull the string vertically downwards. So if we hold the string like this with the pen bob at the bottom, it will have its weight W, which will pull the string downwards like this. And the string in its stretched condition pulls the body upwards by force. And what will happen? The weight will pull the bob downwards, and the string which is there, that will pull the bob upwards. The weight will pull downwards, and the string will pull upwards. Okay, which will balance the weight of the body. So this force is known as tension. Here, so from the picture we can see this is the surface on which the string is attached to, and this is the mass. This is the mass with the object which is being suspended. Okay, this is the string. Now, the mass has some weight, the body has some weight, so that will pull it downwards due to its acceleration due to gravity. And what will happen? The thread will try to move, to pull the body towards it. So that will be creating a tensile force. So that is known as tension force. Here. Next we come to spring force. If one end of the spring is kept fixed and its other end, which is directly proportional to its displacement and is inserted in the opposite direction to the direction of the displacement, this is the spring or resistance. What happens from the picture you can see, one end is fixed. The spring's one end is fixed and the other end will have an object. So the object will stretch the spring. Okay. Objects, due to its weight, it will stretch the spring. And the spring will have a force which will pull it towards it, that is compress it. Okay. So that extension and compression, that is known as, that means it will force like that tension force, it will compress it, it will make it closer. So that is acting opposite to the direction of the spring. So that is known as spring force. That means it is proportional to its displacement, same to its displacement, and is exerted in a direction opposite to the direction of the displacement. Okay? It will make the spring compressed. Now we come to tension force. What is that? When two bodies collide. Okay? When two bodies collide. This is not collide force. This is not tension force. This is colliding force. Collide force. Okay? So what happens when two bodies collide? They push each other, resulting in equal and opposite forces. Force of action and force of reaction acting on each other. This is collide force. This is not tensile force. Please correct it. Okay. So let's say two bodies are taken, A and B. Okay. Now two bodies are moving towards each other. They will collide. Okay. There will be a collision between them, and a force will be acting on A due to B. On A, B will exert a force, and on B, A will exert a force. Okay. So this force due to collision is known as collision force, colliding force. So what happens due to this? The ball A will move in the opposite direction and B will move in the opposite direction. Due to collision, when there is a collision, they will move This way, it will move towards left and B will move towards right. Now we come to non-contact forces. So what are non-contact forces? When there is no contact, when the force experienced by bodies, even without being physically touched. If you don't touch also, there will be some force active there. So that kind of force is known as non-contact forces, force at a distance, you can say. Like electrostatic force, gravitational force, magnetic force. Now, what are those? First, we come to gravitational force. The body on a force due to Earth's attraction is known as force of gravity or gravitational force. In the universe, all the particles attract one another due to its mass. Okay? So, what happens if we throw a ball upwards? Okay, if we throw a ball upwards in the air, it will come back towards the Earth, due to the Earth's gravity. So what happens? There is a force acting which is pulling the ball towards itself. That is known as gravitational force. Okay. Now, electrostatic force. We know that like charges repel and unlike charges attract each other, right? So that is basically electrostatic force. So what do we see if we say, like, if we have combed the hair with a comb, then what we will see if we take some bits of paper and we uh, take that comb which we have combed it, and take it near some bits of paper, we will see that the papers are attracted by the comb. Why? This is due to electrostatic forces. Or we can see that lightning striking the earth. Okay. This is also due to some electrostatic force. Because lightning is occurring in the sky. Why it is coming down to earth? There is also some electrostatic force factor. So these kind of forces are known as electrostatic force. There is some static electricity being happening, and after that, which creates a force, and that is known as electricity. Then magnetic force. A force, here also magnetic poles, we know like poles repel each other, unlike poles attract each other. So what happens? If we take a magnet, we will see it will attract some iron things, iron particles or iron subjects. So that force is between the magnet and the iron object. These are known as, this is also a magnetic force. This is a magnetic force which is helping the magnet to attract this iron objects. So general characteristics of the non-contact forces. What are the general characteristics? The gravitational force is always of attractive nature. Gravitational force is always attractive, which is always pulling it down. But the electrostatic and magnetic forces can be either attractive or repulsive. Because we know that like poles, but like charges repel each other, but unlike forces, unlike magnetic forces, or unlike poles, or unlike charges, they attract each other. So they can be attractive or repulsive, but gravitational force is always attractive. It always attract towards itself. The magnitude of these forces depends on the distance of separation between them. So the magnitude, the amount of forces, that will be depending on what? The distance of separation, how much distance is there between the objects. That it decreases with the increase in separation. If we increase the separation, if we increase the separation of the distance, then the magnitude will decrease, and it will increase if we decrease the separation. It's inversely proportional. So magnitude is inversely proportional to the square of the distance of separation. That means separation doubles, forces becomes one. Separation becomes half, forces become 4 times. Clear? So it will be equal to square of the distance of separation. So in my next video, I will start with the laws of motion. So first will be the first law, Newton's first law, which we will know as inertia. So let us discuss in my next video. Okay. So till then, please go through this. If you have any doubts, please write in the comment box. If you are liking the videos, press the like button, share with your friends, and so that they can also benefit from these videos. Please don't forget to meditate before you start it. Okay. So thank you for joining.